Hello everyone. In this video we will just briefly go over the data types in TIA Portal. In TIA Portal we basically have about, I think, over 60 data types. Some of them are rarely used, some of them are common, and I would like you to think of a memory as a wall full of shelves, and the way Siemens does it is we take a portion for inputs and another portion of the memory for output, and we call that output memory, and the previous one input memory. So we have input memory, output memory, and the largest section would be just the memory. So when we declare a variable, we need to define its name or a tag name, since Siemens now is a tag-based system, just like most of the other manufacturers as well. In the past, it was a rack-based system, and it gives you less flexibility. However, with tag-based system, you have way more flexibility. So here we go to our PLC tags. I will add a new tag table. Okay, it's called tag table 1. Okay, let's go there. And let's see the data types. So these are all the data types we have. Of course, the data types will change from a PLC series to another. For example, here we have S7-1500, which is the strongest PLC series, and we have other PLCs such as S7-1200, S7-300, and 400. They have some older types of some older data types, and for the S7-1200 they don't actually support 64-bit data types, so they are limited to data types that are 32 bits or less. As for S7-1500 supports almost all of the data types. Okay, now let's discuss the data types briefly one by one. So the first one here is AOM underscore identify, or ident, is used to identify any event. It's basically event any identification. And the second one is bool. You all know what a bool is. It just either true or false, or 0 or 1, just one bit. And a byte is just 8 bits. Char to store alphabetical letters or string or text. It's of course a char just one letter. And then we have connection any, which is used to identify any connection. And we have a lot. Of course, we have the counters. It's like basically allows you to start an instance of an object or a function block to have more than one counter. And then we have the date and the database, and then we have the double integer, which is like an integer that is 32-bit. And we have the double word, we have the events as well here, and the hardware and the interrupt types. Integer, long integer, long real, long time, and long is usually 64 bits, as it's supposed to be four words, whereas double words is just 2 words. So double word is 32-bit and long is 64 bits. And then we have time of day, unsigned double integer. So that tells us that it's 32 bits and it's unsigned. That means That means this integer is just positive all the time, so it can't really have negative numbers, and this is usually determined by the most significant bit or the last bit on the left, which determines if it's going to be used for a signal or a sign. For example, is it a positive number or is it a negative number? Whereas in unsigned integers, the last bit is just used like any other bit, and the value of the last bit would add to the value of the integer. So for a 32-bit unsigned number, it would have up to between 0 to a huge number, maybe over 4 billions, or yeah, like maybe 4 billion, something, a long number. Whereas with signed integers, it would take negative numbers, but the positive number would be much less, like the range would be much less in the positive range, and it will also have a large range in the negative scale as well. Okay, that's when we reach it unsigned. And then we have the real, which is used usually for float numbers. Word char, and unsigned short integer, unsigned long integer, and unsigned integer, unsigned double integer, etc. Okay, so basically, to declare a new variable, you can leave it as is, just the system will assign a tag for it, or you can just name it anything. Let's say switch, for example. So you will make it a switch, or let's say switch 1. Okay, assuming that we have multiple switches, and each switch of course will give you either 0 or 1, so this one will be a bool. Once we say a bool, that means it's only one bit, either 0 or 1, true or false, and then we can specify the address. We can say it's going to be an I, which means input memory section, and Q, which stands for output memory section, and M. These signs are different from a manufacturer to another. For example, Delta use X, Y, etc. Other manufacturers might use different symbols as well. So let's say it's going to be an input switch. So we will select I, and address is going to be 0. That means it's byte number 0, and the bit number is 0. So each byte is 8 bits, so we can select the bit number. So we will say I 0.0 or I 0, 0. All right. So that's the address. Of course, the address is taken in another table here, so that's why it's already booked. That's it. Let's say, okay, I'll make it I 0.4. That means the 4th bit, or actually the 5th bit, and byte number 0 for the input memory, which is bit number 4. Okay, let's say we have a value for something, value sensor. Okay, let's say this one will be an integer. Okay, and just by saying integer, that means it's actually signed, so it has positive and negative numbers. Integer in Siemens is 16 bits, so it has a value of 32,767 positive, all the way down to negative 32,767 or 768 negative as well, something like that. And if you want to make it unsigned, like you just have a positive range between 0 to 64,000, I think 565. So we would say unsigned integer. Okay, so that's the difference between integer and unsigned integer. So let's say it's integer, and let's assume that it's an input memory, or let's make it output this time. So we will say it's output Q, and since it's 16 bits, that means it uses a word. Here we can say Q word 0. Okay, that means it's the first word in the output memory section. And the next word in the output memory section will not be word 1, rather it will be word 2, as the word is 2 bytes and it's usually named with the first byte in the word. So the first word is Q word 0 to Q word and so the first byte. The first word is Q word 0, which includes byte 0 and byte 1. The second word would be QW2, which includes byte number 2 and byte number 3, and that's why we use the symbol QW2. Okay, that's address. So that's the beginning of this variable, which is value sensor, and value sensor will be in QW2, so value sensor will start in output memory byte number 2 and byte number 3. So it will take all this area, the 2 bytes, 2 and 3. We also have the word data type, and it's 16-bit as well. The difference between word and integer is that an integer is usually used for arithmetic operations, like addition, subtraction, multiplication, division, etc. And of course it's an integer, so it's not a float, it's not a real number, it's not a real data type, okay? Whereas a word is usually used for, let's say, digital operations, yeah? We can say digital operations on this part of the memory. For example, we can use it for bit manipulation and shift operation and shift rotation instructions, etc. Okay, so that's the difference between integer and word. See, it automatically assigned word to QW2 because there's nothing called QW3. It will be accepted, but actually you're using byte number 3 at the moment, so you're having part of the memory that is assigned for value sensor, and let's say the sensor reads something, and then later on you add other values in word 3, so you're actually changing half of the bits used in our other variable, which is value sensor, so you will have wrong information and wrong values in both variables. So be careful and don't assign a shared memory area between more than one variable, okay? So this should be QW4 for sure. Okay, let's see. Okay, let's say that we would like to make another variable. I'm not gonna rename for now, but just it will name automatically tag 5. Let's say this one will be a bool as well, and I would like to make it an input memory, and I'd like to put at position 1. I don't know if position 1 is used or not. Of course you don't have to worry about it, because the system will just give you a highlighted cell here to indicate that it's used, so you have to change it. And see, it's actually written here. Yeah, this address is already used by another tag, so you can change it. And if you know which tag is actually using this position, we can just go, we can right click our PLC here and choose assignment list. This will give us a graphical overview of our memory, and we can know which parts are used and which parts aren't used. So here we have the input and output memory. Okay, that's output memory used, QB00, and the tag name is rotate left, since it's only, this will be of course a boolean because it's only using one bit, and that is bit number 2. So oops. Okay, so rotate left is just a bool variable for sure. We can see it here, rotate left, yep, Q 0.2, and just a bool. We can go back to our assignment list, and that's another variable. And here, these 4 positions, these 4 bytes, Okay, 4 bytes, that means it's 32 bits, so it's usually gonna be a real variable to tell us the information. Since it's a position, the tag name is position or sent position, so let's go see it in this tag table. And a position is actually a real it's sent position is actually a double word, so it's 32 bits, and it's located at QD30. So the output memory byte number 30, 31, 32, and 33. Here is our assignment list. It starts from QB30. QB B here stands for byte, and we have the byte 30, 31, 32, and 33. So that's how the memory is organized, and that's the memory area, and that's a timer's memory area. These are the counters memory area as well. All right. That's how the memory is organized in Siemens PLCs, and it's very similar to other PLCs as well. There might be like slight differences in names and the addressing method or the addressing terms. It's not really confusing. Once you understand it, for any manufacturer, you'll be able to use it. I hope this video was helpful, and I hope you have enjoyed. Thank you.